All right, so here we want to solve again. And so this is just match problem 3, so I just took it out of the book straight. And so we want to maximize P subject to these constraints. And so what we need to do is we need to add in our, this case, slack variable. This case, we're going to subtract off a surplus, but add on artificial. And so let's just put it all here. So we're going to maximize P equals 3x1 plus 2x2. I'm going to leave it blank, subject to, and we have x1 plus 5x2 plus s1 for slack equals 5. And again, this is slack. And then I'm going to have here a 2x1 plus x2 minus s2 plus a1, and that's equal to 12. So here we have a surplus and an artificial. And because of that artificial, we have to subtract that off of our objective times the m. And when we do that, then we have what? We have x1, x2, and we add s1, s2, a1, all greater than equal to 0. All right. So let's put this one in terms of equal to 0. So it's going to be what? Minus 3x1 minus 2x2 plus ma1 plus p equals 0. And so then if we put that into our preliminary tableau, we have x1, x2, then we have s1, and then we have s2, and then we have a1, and then we have p. And then we have what? 1, 5, 1, 0, 0, 0. Then we have 5. Then we have 2, 1, 0, minus 1, 1, 0, 12. And then we'll put our bottom row, which is a what? Minus 3, minus 2, 0, 0. And then we'll have an M. Yeah, M. And then we have a 1. And then we have a 0. Okay. And so doing this, now we have to take what? We have to take a minus m row 2 plus row 3 goes to our new row 3. And let's see if we can get this to work here without having to put anything. And so that's going to be a 1, a 5, a 1, a 0, 0, 0. And then we'll have a 5. Then we'll have a 2, 1, 0, minus 1, 1, 0, 12. And minus m times that, so it's going to be what? A minus 2m minus 2m, and then minus 3, and that's going to be a minus m minus 2. That's going to be 0, and that's going to be what? Positive m. That's going to be a 0. That's going to be a 1. That's going to be a minus 12m. And so now, what do we have? We're going to figure out which one's the most negative. Well, the most negative looks to be probably this one that looks like maybe here. And so because of that, then we're going to have to go and do our work from there. So that's going to be on the next page. All right, so then we move to the next page. So then we're going to have works here. There we go. X1 or X2, S1, S2, A1, P. And then we have S1, A1, and P. And so, let's see here. What did we have to start with over here? So we had that. So I'm just going to rewrite this with the things on the side basically, and then we'll go from there and try to figure out where the most negatives and stuff like that are. So we're just trying to make it so it fits, so I can fit it onto one page hopefully. So 5, 1, 0, 0, 0, and that was a 5. And then we had a 2, 1, 0, minus 1, 1, 0, 12. We had a minus 2m minus 3 minus m minus 2, 0, m, 0, 1, and a minus 12m. All right. So the most negative would be, it looks like that one. And so if we take our quotient, That's going to be 5 divided by 1, which is 5, and 12 divided by 2, which is 6. That's the smallest. And so now let's circle this. And so how do we do that? Well, if we take a minus 2 row 1 and add it to row 2, that's going to be our new row 2. If we take a 2m plus 3 times row 1 and add it to row 3, that's going to be our new row 3. And doing that, this is going to enter, and this one is going to exit. So we'll have x1, a1, p, and this is x1, x2, s1, s2, a1, p. And so first row stays the same. Second row, minus 2 plus that, 0. And that's going to be what? Minus 9. Okay, minus 9, minus 2, minus 1, 1, 0. And that's going to be what? A 2. And that's going to give us a 0. It's going to be 10 minus 1, so that's going to be a 9m. That's going to be 15 minus 2, so that's plus 13. And that's going to be 2m plus 3. And that's going to be what? M. That's going to be a 0. It's going to be a 1. And that's going to be 10 minus, that's minus 2m plus 15. Okay. Now, notice the indicators are all 0, so all positive. So we're going to stop. But now notice artificial variable is 2. Now, if we go back a ways, a long ways, we have if any artificial variables are non-zero an optimal solution to the modified problem, then the original problem has no optimal solution. So, because this says A1 is equal to 2, then there's going to be no optimal solu solution. Okay, so that's kind of a key thing. Sometimes you're going to end up with your artificial variable still on this side, and it's going to have a value, and that value makes it so there's no optimal solution. So I'll stop there with the hand ones. I'll come back at another time and I'll show you how to do these on Excel.